So I got the chat.openai that Arlo sent me an email with. I was looking into it and I got it to write us a problem. I just typed in, write me a radioactivity half-life problem. So let's try it. Here's the problem. It says we've got a sample and the substance has a mass of 100 grams and a half-life of 10 years. So first of all, write an equation that represents the decay. And then how much of the substance is going to remain after 20 years? And then how long will it take for the substance to decay to a mass of 25 grams? It's like not a terrible problem. It's pretty easy, but let's do it anyways just for fun. And so you can pause it if you like and try to do that. And then you can come back to this. It's probably a good idea. Okay, so chat OpenAI problem. So first of all, we have mass is equal to 100 grams, and our half-life is equal to 10 years. So I write an equation. Now, I would say that the equation is n is equal to n naught e to the negative lambda t. That was the equation that I would give. And then it's funny because I just typed in after that, and I would show you on my phone, but I'm using my phone to film this. I just typed it in, solve the problem for me, and then it did. It gave me this formula. It said, basically, it said n is equal to n naught times 1/2 times t over the half-life. This is what the chatbot gave to us. And that's true. It's a little tougher to work with because this one doesn't have the lambda, and it's a little trickier with certain situations. But let me show you why this is actually still correct. And so basically what it's doing here is this is the number of half-lives, right? My pen is running out here. Sorry, you can't see that. This is the number of half-lives, t over t to the half. Okay, so if time is 4 years and your half-life is 1 year, you got 4 half-lives, right? Okay, so let's see if we can derive our E formula. If I take this over here and I say n over n naught, and I'm going to leave this back a little bit to the power of t over t half, I can ln both the sides here, all of that and all of this. And what I'm going to get here is this exponent can come out in front of the ln part. So I'm going to have t over t half, so time over half-life, times the ln of 1/2 is equal to the ln of n over n naught. Okay, so we've gotten our exponent up here down now. And now what I can do is I can basically make all of this into an exponent of E, and all of this of an exponent of E. And this just disappears. So over here, this is just n over n naught. And this is now e to the power of all this, okay? So this is e, and I'm going to write it like this, the ln of 1/2 times t over the half-life. Now the ln of 1/2 is the ln of 1 minus the ln of 2, right? If we think of our, should I write that out? I should just write that out. This is the ln of 1 minus the ln of 2 times this stuff over here, okay? The ln of 1 is 0. So this is e to the negative ln of 2, half-life times t. We said that lambda is ln of 2 over the half-life. So this is e to the negative lambda t. And you see that these two answers are really the same. Okay. So that would be your equation that the chat wanted us to do. We're all going to get taken over. You know, this is the end of the world, right? Chatbot. Okay, so the B said, how much did the substance remain after 20 years? So this is actually a super easy question, right? You have 100 grams, and the half-life is 10 years. So if we have two half-lives, you're going to go down to 50, and then you're going to go down to 25. So the answer here is 25 grams. But it's a very simple problem. But let's just use this as a simple example to test our formula. Okay, so if we said that n over n naught is equal to e to the negative lambda over t, then because our number of nuclei is equal to the fraction of mass, we could also say that the mass over the original mass is equal to this same thing, right? And so, now we have to find lambda first. So lambda is the ln of 2 over the half-life. And so if you do the ln of 2 over ln of 2 over 10 is the half-life. Oops, can't do that. Got to finish this bracket. So my lambda would be 0.0693. That makes sense. That's my lambda. And then if I multiply that by my t's, the chatbot said what's going to be there in 20 years. So if I take that and then multiply that by 20, that's going to give us this exponent. And then I'm going to turn that negative, and I'm going to put that as an exponent of e. So I did the second division and get the e, and then put to the power of this. And we get 0.25, and if I multiply that by my 100 grams that I started with, I get 25 grams, and yay, everything is correct. So if you put everything into that formula, you're going to have 25 grams. Now, the chatbot didn't come up with such a great question for us, because now it's going to ask how long will it take for us to decay to 25 grams. So I'm going to change that one. I'm going to say, how long will it take to get to a mass of 1 gram? So if you measure it later at 1 gram, how much time has gone by? See if you can figure that out. Pause that. And I'll do it here. So if we say m over m naught is equal to e to the negative lambda t, we must now solve for this t. So we're going to say the ln of this side is equal to, and if I ln all this, I just end up with negative lambda t. And so if I ln, and I'm going to put the numbers in here, 1 over 100, that'll be 0.01 divided by my negative lambda. That should give us the time. And if I do that, I know my lambda from before. So if I just do the ln of 0.01, bracket it this time, divided by negative 0.0693 it was, I get 66.5, and that's going to be years or so, 66.5 years. And if you work that out to kind of satisfy yourself, if you hit half 6 times and then go to the 7th time, I think you'll find that you'll go through 1 gram of material. So there's a chatbot problem, a little bit of practice.